Thank you for the introduction. I'm happy to be here in South Africa, my first time in South Africa in Johannesburg. So happy to have the chance to present at this conference. So what I'll be talking about is, like you just said, the added value of building a converged fiber to the home 5G network. This is based on a case study that we did earlier this year, part of last year as well, together and for the FTTH Council in Europe, with cooperation of the many FTTX councils around the world. Also a lot of industry partners and members of those councils provided their input for the study, validated our assumptions for the study. And so the results were presented at the FTTH conference in Amsterdam earlier this year in March. And the results were picked up by numerous news websites around the world. So what did the study focus on? So what we focused on was, we looked at the cost for deploying a fiber to the home network in different types of areas, different types of population densities. We looked at what would it cost to deploy fiber to these to 5G sites spread across these different areas, also looking at different types of cell densities. And we were wondering, okay, what's the cost reductions that we can realize, so the total cost reduction, but most importantly, what's the extra investment that would be needed when deploying to each and every single home, but taking into account future deployments of 5G antenna sites and already putting in the infrastructure. So what's the extra cost for this, and then what's the amount of cost reduction that you can realize by not overbuilding in the years to come for your 5G network. Now, I will, in my introduction, also talk a bit about 5G. Like it's a big topic I've noticed at this FTTX conference. This is really not a fiber to the home conference anymore. So a few points that I will touch upon on 5G, on why we looked at this study and which elements of 5G are important for this study is really the advantage that it will bring. So the higher bandwidth capabilities over wireless transmission, but meaning that you need a big backhaul pipe to each and every single antenna site. Next off, the low latency capabilities, allowing new and different use cases and applications. But of course, the more downside of things is that the reach of your antenna sites will be lower because of the higher frequencies that you will be using. So a lot of small cell sites that will be distributed within your area or target area. Now, some of the things or uncertainties at the moment that I've seen, that I've heard of talking to different operators is in which frequency bands will I have spectrum, how much spectrum will I have available for my rollout? And the second thing is how dense will my 5G network be? So we know the reach will be lower, also depending on the frequency that you're working on. So, but how dense will my network be? And we tried to take that into account for this study by looking at different types of densities. And then third off is the use cases. So what will be the killer application for 5G? What will make my business case for 5G when I'm a network operator? So there's different types of use cases that look very interesting for 5G. But I have the feeling that operators, network owners are still deciding on what type of use case will build my business case, and this will require different elements of the 5G standard. Now, one of the advantages of 5G standard is the broader range of spectrum that will be available that can be utilized to offer these higher bandwidths. So, in comparison, for 4G, we're looking at sub 6 gigahertz frequency bands. For 5G, that ranges to 100 gigahertz frequency band. Now, For this study, what we did, we looked at a sub 6 gigahertz network. So we looked at network on 3.5 gigahertz, and then also a millimeter wave network on 26 gigahertz to offer these higher speed, higher bandwidth. Of course, this is just looking at two different frequencies. Who knows what the future will bring, where we look at even higher frequency bands, what will happen with 6G. It was touched upon as well in the previous session, so we know this is coming. So the things that we investigated in this study will still hold up, but will have to be renewed for future networks. Now, what I touched upon earlier is, okay, when we look at these higher frequencies, it means that our coverage, our reach from a single antenna site will decrease. So for this study, we worked together with a company called Cyrodiil, who has a very good mobile planning solution, mobile coverage solution, and they can really map out what will be the reach from a particular antenna site, considering all of the assumptions on transmission power, receive power, and signal to noise ratio, and so on. And looking at a 5 gigahertz antenna site, you can see you can reach a couple of hundred meters from that site location. Going up to 60 gigahertz, that reach, that coverage, already decreases to sub 100 meter. So if you want to roll out a network within this frequency range, at this frequency range, you will have to deploy a lot of sites if you want to get to a fully covered area. Now, so what I showed with the previous slides, okay, my reach will be lower, my coverage from one site will be lower. So we're looking at massive densification of the network compared to 4G macro cell sites. Now, to be able to offer the bandwidth, we're looking at fiber front haul, fiber back haul much more. And so we're looking at putting a fiber almost in every street or every couple of blocks. Fiber will be needed to serve these antenna site locations. So looking at conversion is a reasonable thing to do, and it's a smart thing to do, and that's what we looked at in this study. Now, in this study, we looked at 3 different types of areas, so that we're able to coverage a wide type of scenarios, deployment scenarios across the world. So what we looked at an urban area, so a lot of high-rise buildings, a lot of visitors within the area that require mobile connection. We looked at a more suburban area, so single dwelling units, but closely packed together, roughly 3,500 inhabitants per square kilometer. I quickly checked for Santon there, we're looking at 1,500 inhabitants, or 1,500 residents per square kilometer here. So you might say it's quite comparable. And then we also looked at the rural case, so just single dwelling units spread out over a large area, less than 100 inhabitants per square kilometer. Now, what I want to explain in this session is really explain the type of modeling that we did, so how we approached the study, to show you that the numbers that we're talking about, they're not pulled out of thin air. They're really based on very detailed modeling, and I want to show you that you can apply this in every single area, every single scenario that you might be looking at as well. So we use 2 different modeling tools. One is Cyrodiil's 5G propagation modeling tool, so for determining the mobile coverage, determining where to put all of the cell site locations. And we use our own Comsof fiber FTTX modeling tool to determine which type of cables to put in, ducts to put in, where to do trenching. really on a geographical level, so really on a detailed street level, actually. So the things that went into the 5G propagation modeling tool is information about the frequency. Like I said, we're looking at 3.5, 26 gigahertz. The target coverages, so we looked at different types of density scenarios and coverage scenarios. I'll go into that later. And then technical parameters about small cell site locations and so on. We fed it 3D area data, so really, data was captured in the field for each particular area, knowing the height of each building, any trees that are in the area that might influence your mobile site planning. And we fed it a large set of candidate sites for each area. This gave us a number of selected sites within each scenario that we looked at. And then we used our FTTX modeling tool to estimate the cost for the total deployment, looking at the outside plant infrastructure, so the infrastructure that could be shared between a fiber to the home deployment and a fiber to the 5G deployment. For our modeling tool, the type of parameters that we had to configure, input data that was required, and which was also verified with all of the members and industry partners from the FTTH Council, was information about the fiber to the X, so the home and 5G architecture that we're looking at, whether it's PON or point-to-point, this kind of things. Type of materials that we use and the costs for each type of material and civil works that we need to be able to deploy such a network. We also fed it 2D area data, so information about how the streets are laid out in the area, point locations for each and every single home in the area that we also want to cover with our fiber to the home deployment. And so this gives us information about what it would cost to deploy a fiber to the home scenario or network in each area, fiber to the 5G, and then a converged network deployment. Now, looking at the type of data that we used for the mobile planning side of things, so we used 3D LiDAR data for each and every single area, so very on a detailed level, the type of information that you need to do proper mobile propagation modeling. And then as an input, like I said, we used a large set of candidate sites, and what we used as candidate sites are all of the lampposts within the areas. And this gives us input data more or less like this. So what you can see is we have a 3D digital map for every single area. This is now looking at the high dense area, which is located in Paris. And all of the red dots, but they're very closely together, so you get a big field of redness there. Those are all our lampposts that we fed as candidate sites to our modeling tool. And so what I said is for our mobile planning side, so for our 5G modeling, we looked at different types of cell densities. So the way that you can look at this is, this could be like a multi-year rollout, going from low cell density to a high cell density. So this is really an incremental, this can be an incremental build, just going step by step depending on the need within the area. To give you an example, for our medium dense area, we considered a low cell density scenario as we have 100% coverage on 3.5 gigahertz, but only 25% coverage with our small cell sites at 26 gigahertz. And then moving upwards, medium cell, high cell density, up to 95% coverage for our small cell density. And I'll show you later what that looks like in terms of number of sites that will need to be made available within your area. We did the same for a high dense area, low dense area, really looking at the needs for each type of area. Like I said, for high dense area, we took an area with a lot of high-rise buildings, but also a lot of visitors, maybe a lot of tourist sites or train stations that are highly visited. So there we also looked at placing indoor hotspots that we want to connect even for our low cell density scenario. While for our low dense area, so our rural deployment, we didn't look at deploying a small cell 26 gigahertz network, but only looked at providing a connectivity on 3.5 gigahertz.